Hey there, everyone, and welcome to today's webinar. So good morning, good afternoon, good evening, depending on where you are. Turn on my webcam so you can see me and so I can say hi. So today's webinar is packed full of information, and I hope it's of use to you. And so as you may know, my name is Ted Young. I am a Java trainer and technical coach. And I do a lot of teaching of not just Java the language, but also how to structure code. And this webinar came out of a presentation I gave a couple of weeks ago at Agile 2019, and it was popular enough that people were like, oh, I wish I could have seen it, but I was at something else, or I be great if I could have a colleague see it. So that's why I'm putting on this webinar. So I'm giving it today, and I'm also going to give it again in September. And this also forms a large part of an online course that I'm putting together. So this sort of forms the foundation of that. All right, so let's get started. So go ahead and type in the chat how you heard about this webinar, whether it was a colleague or you saw it on Twitter, or maybe you heard about it on an email list. Go ahead and type that into the chat area. Yes, and thank you to Mike Rizzi for telling other folks about it. So one thing I wanted to point out is that there's a slight delay in the time that I say something and you respond. So if it seems like I'm taking a little bit of time to respond, that's just the network delays. And oh, great. Yes, Jeff from Exxon. Awesome. Oh, cool. All right. So some folks also from Agile 2019. Great. Okay. So in general, I'd like you to hold questions to the end if you can, but if you feel like you're going to be lost for the rest of the webinar if you don't get a certain piece clarified, then go ahead and ask your question. So I'll have some time, a little bit of time to hold questions at the end. I've timed this webinar to be about 55 minutes, and so there's not a lot of time for Q&A if you've only got an hour scheduled. But I will actually stick around until all the questions are answered, however long that takes. So I'm curious, go ahead and type in the chat what your current programming language that you're working in is. And the reason I ask that is while the code samples I'm giving here are in Java, I believe and have actually applied this architecture to other languages such as JavaScript and PHP. I've worked with some clients who are doing that. Yeah, and C# is going to be pretty similar. Cool, some Java folks too, yay. All right, so you've probably seen this kind of architecture diagram. What's sometimes referred to as the vertically layered architecture, or sometimes also referred to as the cake architecture, because it's got layers and built upon layers, built upon layers. The problem with this diagram is, first of all the layers necessary at all times? Are the layers of equal importance? And from my experience, having the database at the bottom tends to get people thinking about the database first when they're designing their applications. And this can cause a number of problems because it means you are database-centric instead of business-centric. And for me, one of the most important things is getting the business logic that you need done and getting that the focus, especially in an object-oriented language like Java and C#. You want to be able to write good OO code. But if you're sort of having the database force you to do things, then you may not end up in having as good OO code as you could otherwise. And so I saw this comic, and it's sometimes a little bit scary about like, well, okay, we have all these layers. What do we put in them? How do they relate to each other? I no longer know what to call some of these layers. But even in the simplified diagram, the DB is at the bottom, which is kind of amusing. So one thing many years ago, we learned this idea coming from Agile is this idea of implementing thin vertical slices. So this gave us the idea of if we want to implement a small feature or even part of a feature, we would probably have to slice the thing vertically. And this is sort of along with the vertical architecture, basically probably hitting most of the layers, but not always. And they're not always the same size in each layer. And so, we keep adding features and doing thin vertical slices. But what that hasn't helped us with is the potential for coupling across these implementations. So if we removed one of those features, because maybe we did some experiments and found that we had to rework it, did we unintentionally cause code in the other features to be affected? And so we'll see that hexagonal architecture can help a bit with that. The other problem is that it can lead to organizing your code according to the vertical architecture. And every time I teach this, I always sort of say, show hands if you've seen this architecture. So type in the chat if you've seen architecture in your code reflected in this way, where you've got a package for controllers and a package for models and a package for services. It can make it very difficult to find out where things are and where things relating to a certain feature are. So let's look at hexagonal architecture. So it all started with the infamous hexagon, and it was good. Alistair Coburn, one of the original Agilist folks, who really gave me some of my first guidance in some of his early papers in the mid-90s about how to design good OO. And I had just been starting with Java at the time and coming from, of all things, Visual Basic, and really struggling with just what is good OO. And so some of the early Coburn papers really helped me out with that. And so Alistair came up with this pattern, which he originally called ports and adapters, and then which originally actually called hexagonal, but then changed it to ports and adapters when he clarified the use of adapters between the inside and the outside of the hexagon. And this quote from the pattern, I think, is really an interesting read. So I'll let you read this for a bit, and then we'll talk about why I think this intent is so interesting. So I think there are two key parts here. One is that this idea, which I think is still not widely recognized, this idea that you can drive the core of your application equally by sort of its natural use by users and other programs, that today that would be other APIs, as well as automated tests. And the other part, that we can develop and test things in isolation from the runtime implementations. And I think both of those are amazing that still holds up today. And so when I was researching for this presentation a few months ago, I read this over and I'm like, wow, this is really awesome that it still applies today. And I wish more people would read it. So this was one of his original diagrams from the original write-up that Coburn created. And so you can see here, he's got this idea of two hexagons, this core thing in the middle called the application, and then this outer one, which is sort of the boundary between the inner think, between the inner part and the outside world. And yeah, there's this left-right asymmetry, and we'll actually look at that. So one problem that I had with reading his original write-up is it wasn't quite detailed enough. And I found that it took me years to figure out all the nooks and crannies and details of how to get this right. And that's why I've been really talking about it a lot, because I feel like I finally got it. So, as I mentioned, I actually prefer the name hexagonal architecture over ports and adapters. The reason why is because I think ports and adapters focuses a bit too much on just the boundary, and I think that the core or center part of the hexagon, basically the inside, is actually also important. And I think now that domain-driven design has become somewhat popular and known, and I'll talk a bit more about that, it works really, really well with the hexagonal architecture. So we've got the inside, which is the important business bits, and then we've got the outside. And so that's sort of the way we look at the hexagonal architecture. There's a lot of the stuff on the inside, and we'll dive into that. And then there's things on the outside that we need in order to interact with the rest of the world. Before we dive more into that, there's an important question that comes up, which is, do we draw the diagram flat-topped or pointy-topped? And so I use pointy-topped because, first of all, I want to remove this idea of the ability to sort of stack these things vertically, because I think we got into trouble with that with the vertical architecture. The other thing is I really like that the left-right symmetry is much more pronounced on the pointy-top. So I go with the pointy-top, and let's look at the things in the outside world. And they're basically, Alistair talks about two types of things. One is coming in from the left side are the triggers, or sometimes called the driving use cases. And so these are the things that are triggered by actions from people, clicking on a button on a UI, or maybe sending a text message on a phone app, or some message coming in from a message system. And then things happen on the inside, and then maybe or maybe not, something happens on the outside. And so these are the driven, these are sort of also called secondary things. And these are outcomes that might be persisted to a database, or further events generated to send to some other system. So on the left, you might have a button being clicked, some processing inside that is all the business processing, and then maybe triggers the sending of a message to a shipment system on the outside. And what's nice is that this lends itself very well to some of the event-driven, event-sourced kinds of systems. Not quite event-sourced, but more the event-driven that is pretty popular in the domain-driven design community. So the code and sort of the architecture that I've been using that I'll be using to talk about this comes from a product that I've been working on called Kid Money Manager. I've been live coding it. You can grab the source code. It's open source. You can look at some of the early videos. They're up on YouTube. Basically, I developed this live on Twitch. And so let me talk a little bit about the product. And so here we can see two different user interfaces that interact with the system. And so the idea is this is something that I want to that I'm using with my son to keep track of how much money he has. Since he's only 14, he can't have his own bank account and debit card. And so if he, if we're at a store and he decides he wants to buy some Haribo Mini Frogs candy, then it used to be where I'd have to write on scraps of paper, okay, he spent $2.50. Or if we return some bottles for recycling, I'd have to scribble down that, okay, he got, $8 for that. And that became messy. I created a spreadsheet, but then I was the bottleneck for monitoring all the transactions. I said, all right, this is a great project to not only because it's useful, but also to demonstrate some coding techniques like this architecture. So on the left side, we've got the web UI, and on the right side, it's actually not an app, it's actually just text messaging. And that happens to work really well because you don't have to wait for an app to open and connect. Plus, I don't have to write both Android and iOS apps. So that's the application, the Kid Money Manager application. So the overall architecture looks something like this in the context of hexagonal architecture. We've got the core domain in the center that is handling all the business logic. And then we've got things on the upper left, which are the incoming or driving parts of the application, a web user interface and the SMS text messaging. So we'll look at those first, and then on the lower right and the right, we've got the secondary things, which is how do we store the data, and what about communicating outwards to other services. And we'll look more deeply at the ports when we get to that. So I wanted to mention separation of concerns. And there's sort of a quote that always comes to mind that's almost exactly like this. Separation of concerns is a matter about which a great deal is said and very little done. The original quote is not about separation of concerns, it's about the weather, talking about the weather in New England. But whenever I hear folks talk about separation of concerns, this quote comes to mind because it's like, okay, yes, I know separation of concerns is important, but what do we do about it? How do we separate the concerns? Which concerns should be separated? Things like that. And that's one of the things I like about the hexagonal architecture is I feel like it's prescriptive enough to give you those guidelines that are useful. So the idea is we want to separate infrastructure and the outside world from our business logic. And so if we sort of look at it diagrammatically, it looks something like this, right? We've got our outside world stuff on the left, our infrastructure stuff on the right, and maybe we're sitting using a framework at the bottom. So some examples of that is listening to the outside world. It might be a console-based app, that's possible, or an HTTP API or a web UI or messaging, and that's things coming in from the outside world. Talking to infrastructure is database, network files, that typical thing. And your frameworks, Spring, the Java EE, or now Jakarta EE, or Micronaut. And so all of these things are in the outside world, and we want to keep those isolated from the core domain. Because in the core domain, we want to be domain-driven. We want to have domain as the focus of our application. And that means we want to be able to write the code and tests that are only thinking about what are the policies, rules, complex things that we want to do inside the business. And so if you're not already familiar with domain-driven design, this was the book that started it all, written by Eric Evans. And the subtitle is important. It's tackling complexity in the heart of software. So this is dealing with when you have complex business applications, and when I say business, you can substitute complex tools, right? Anything that is basically having complex rules and interactions is going to be something that domain-driven design is good for. And so your domain may not be the business, it may actually be internal development tools or other internal tools that are not necessarily directly connected to your business. So the four patterns that I just want to quickly go over, just in case you haven't been exposed too much to domain-driven design, are entities, value objects, aggregates, and repositories. And so we'll see that entities and value objects work well together as part of aggregates, and then those get stored and accessed with repositories. And so again, this is not a webinar about domain-driven design, but I just wanted to make sure that the language is clear. So entities are the typical things that we work with that hold information, maybe about an employee, maybe about a meal order, that has a unique identity that is separate from the information that it's holding. And so, for example, if you place an order at a fast food place, that order needs to have a unique identifier so you can tell apart the different orders. And this became very clear to me when I was in Washington for the Agile conference. I ordered a meal from the Shake Shack over its mobile app. And when I got there and was waiting around, they called out the name Ted, your order's here. And so I was walking up, and at the same time, this other guy was walking up, and we're sort of looking at each other. And it turns out his name was Ted also. Not only that, so we peered inside the bag to see if we could tell the order apart based on what we'd actually ordered. And he ordered something very, very similar to mine, so we couldn't tell the difference between that. Luckily, he was holding a pager that had a number on it, and that number matched what was on the slip. So that was the unique identifier that identified the meal and showed that it would belong to the other Ted and not me. So identity is separate from the contents because sometimes the contents are the same. Whereas value objects are defined by their attributes. So the typical examples are zip codes, right? 94404, the zip code I live in, is very different and is unique from another zip code, 10003, which would be New York City. And so you don't change those because they're defined by sort of their intrinsic properties. Colors are another example based on their RGB values or the states of things, like the states of something in a process. Now, an aggregate is a group of entities and value objects. So entities usually have value objects. So you might have a person that has an email address that's a value object and a zip code that's a value object. And then a bunch of entities are grouped together into an aggregate. So you might have an order for that meal consisting of individual line items, and all those are grouped together and managed by the aggregate, what's called the aggregate root. So in this case, it would be the meal order to which you add those items. And again, there's a lot of detail to aggregates and entities and so on that there are great references for that. Finally, the repository, which is used for storing and retrieving the aggregates, because you got to find them at some point and you got to store them at some point. You may not need to store them for long, so the persistence mechanism can be different, but this is the pattern of the repository, and you're almost treating it as if it were just some collection that you could search over. So the idea here is that this is in the language, talks in the language of the domain. So the things you're storing in the repository would be things like meal order or account, and not how it's stored in a database or some remote system. So we'll dive it deeper into the repository later on. So an example of what might be in the core domain, this comes from my Kid Money Manager application, is an account, savings goal, a phone number, which would be a value object, the role, whether it's the kid or the parent, because I don't want my kid to being able to deposit money into his own account. That's not allowed. So role is also a value object, transactions, and user profile. So those are all things in the core domain, and those do not then reference anything in the outside world. So what we get from this isolation of separating the core domain from the outside world is, again, as Alistair said, we can develop and test it in isolation from the runtime components. And that means our tests can run really quickly, very reliably, without a lot of flakiness due to things outside of our CPU and RAM. And so this fits very well with Michael Feather's set of unit testing rules that comes from 2005, because I see a lot of tests in systems when I go visit clients where their unit tests are not unit tests because they talk to a database or they communicate across the network. That seems harmless, but that's still susceptible to outside influence that you can't control, or touches the file system. And again, that is the cause for slow and or unreliable tests. So the principle then is that tests must be isolated. And so there are techniques to isolate them, so not only from the outside world, but what do you put in place of the outside world is the whole area of test doubles. And I'll talk about a couple of those, but by test doubles, I mean what are called fakes, dummies, stubs, mocks, and spies. We'll look at a couple of those in a bit. So back to the architecture. Let's zoom in then on the web user interface. And so the important thing here is that the adapters are helping shield us from changes in the outside world. So things in the outside world change often and are usually not under our direct control. And so the adapters allow us to buffer, and what Eric Evans in domain-driven design calls an anti-corruption layer. So the adapters provide that separation between your core domain and things in the outside world. So we've got a person communicating to the application through a web UI adapter. And so they might want to do things like look at what's in my account, or deposit some money in the account. And so you probably have something in your core domain that is a POJO. And I'm using the strict original definition of POJO, so also called POCO in C#. So you may have heard the term to refer to things like that have setters and getters and are used for transferring information, but that's actually not the original use. POJO is our original OO business logic inside of an object. So that's also called a domain object. And so it has not setters and getters, but it has commands and queries. And that's how we send messages from one object to the other. So in this case, we've got a couple of commands to deposit or spend, and a query to ask the account, hey, what's your current balance? Now, the problem is if we want to take this domain object and send some of the information to the outside world, if we're using a framework like Spring that leverages a tool called Jackson, and so what Jackson is looking for is how to translate the information from an object into JSON. That's kind of the typical thing. Or to be used by an MVC template engine like Timely, if you're familiar with that from Spring. And so if you look at the highlighted area, if Jackson tries to examine a count and saying, hey, Jackson knows how to look for properties based on getters and setters, it's only going to find one, and it's going to be its ID, which we may not even want to expose to the outside world. But it's not going to find a balance because it doesn't form the patterns of what Jackson is looking for in terms of getters and setters. And so this leads us to, this also tightly couples a count to the outside world, which we may not want to do. So we've got two problems of, we don't necessarily want to expose everything in a count to the outside world, and we don't want to adapt the account object to work well with Jackson. We want some separation there. So this leads us to a rule I have, which is domain objects never leave. And so that means that the domain objects only live inside of that inner hexagon. Now, when I say never, that's a guideline. There are some cases where you might be able to get away with it, such as for storing in repositories. But in general, I found this rule to be really helpful, both to keep the isolation barrier up, as well as make testing easier. So if domain objects can't leave, then what can? And so the short answer is a special type of object, a data carrying object called DTO, or data transfer object. And in Java, these are Java beans. And again, I'm using the original defined definition of Java bean, which is a thing that has setters and getters on it and doesn't really have any business logic in it. It may have some transformation logic to move to and from domain objects, but for the rest of this webinar, and if you ever talk to me, POJOs are my domain objects with good OO practices, and Java beans are things that are just data carrying things that have setters and getters. And you may talk to people who use the opposite, and I will say they are wrong, and that's a hill I'm going to die on. But first, before we can figure out how to use the DTOs, these data transfer objects, we need to look at the adapters. And so the goal here is to reduce coupling between the outside world and your core domain. So this is what a data transfer object might look like. It's got some private properties and then setters and getters, which are either generated by your IDE or in Java land by a tool called Lombok. And that's cool. We don't really care about a lot of this code. It's basically just for carrying the data across that boundary. And so now that we have that, we can see that instead of transporting the account outside of our core domain, we transform it to an account view in this case, and then Jackson can happily do get ID and get balance on it, transform that to JSON and send it out. Now, adapters are not just single classes as per sort of the design pattern. The role here is actually a set of classes. So it includes any controllers for the web UI or for the SMS text messaging interface, as well as any DTOs that need to be used to transform the objects from our core domain. And in fact, sometimes you're going to have a single DTO carrying information from an entire aggregate, right? From an entire set of entities, and that's fine. So the adapter responsibilities are basically these. We're going to, when stuff comes in, we want to do validation there as much as possible. And so that's the point where we're converting the JSON or text from a web UI into our domain objects. And that allows us to do the validation and constraint checking on things. That way, when we're converting strings to objects and strings to value objects, we're no longer checking to see if they're okay everywhere in our code. Once we've created our domain objects, we can be pretty sure that they're pretty valid. Maybe not completely so, but as much as possible. Then we're going to convert. So that's part of converting it to the domain object. We may send it to some service that is basically cross-cutting, basically behavior that cuts across multiple entities. So we might have a service, and then we're probably going to convert some resulting domain object back to, or set of domain objects back to a DTO, and then return that DTO to the outside world. And this is really key, right? This separation is I found, if you really think about this separation, it makes a big difference in what your code looks like. I know in my code, when I look at where I've had problems, it's usually because I haven't had that good separation. So if we take a quick look at another example with the SMS text messaging, it has its own adapter, because the needs of translating and transforming information from an SMS text message is very different from dealing with a web UI. And so I have another rule, which is an adapter per communication mechanism. You may further subdivide that into an adapter per sort of feature or use case. And Alistair Coburn's original pattern talked about this idea of use cases. People don't kind of talk about use cases much anymore, so maybe it's more like features. And that depends on the size of the adapter. And so we end up with the two adapters here. They're sharing the service because the service is inside of our domain. But what we want to do is also have separation between the adapters. So there's another dependency rule, which is adapters don't depend on adapters. And so this rule is in place so that you can basically unplug or plug in new adapters at any time without worrying that you're going to affect another adapter. And so this helps keep things isolated. And you want to keep things small and isolated so it makes it easy to work with. And we'll see also makes it easy to test. If there is shared code between them, then you can basically create an adapter layer that has that, and that it would be in place for sharing among different adapters. And I'll show you a couple of cases of that. So adapters don't depend on other adapters. And that makes actually testing adapters not only easier, not only necessary, but easier because they're independent. So we want these adapters to be testable, but what we want is to test them in isolation, right? That's one of our principles. And so to test an adapter, we don't need access to the core domain. And because we already have good tests, and maybe even we did it using TDD to develop that core domain. And so now when we sort of want to create an adapter to plug in, we want to make it testable. And so we can test them in isolation. So if we look at this example of the interaction for the SMS text messaging, we can see that there's some parsing that needs to happen, right? So if I say deposit 13 bottle recycling, the system, the Kid Money Manager needs to interpret that as depositing $13.00 and putting in a transaction where the source of that money was bottle recycling. And similarly for spend, and similarly for goals. So it needs to do some parsing. That is specific to that adapter, so it's not actually part of my core domain, but it is part of that adapter. And so I'm going to have a test for that. And this is going to be a isolated unit test. It's because it itself, even though it's in an adapter, does not touch the outside world. It just deals with commands and text, and I can write tests for this and they'll run really fast. Now, that's not always the case, because if I want to test my web UI, I may have to actually use some part of the infrastructure in order to do that. So for example, when I'm testing the web UI in a Spring application, I'm not really interested in testing how it talks to the service inside of my core domain and how my core domain works. I'm mainly concerned with, did properties, parameters get transformed correctly? Did routing happen correctly to the correct URL? And so you can see in this test, I'm doing things like, I'm making sure that /deposit is a valid URL, that the view name is correct, that there's attributes in the model, or that in a post, I posted the correct parameters and they result in a redirect to the correct place. So question about DTOs live in the app service. No. DTOs only live in the adapter. And we'll look at on the other side and the flip side when we get to persistence that Anything inside of the core domain does not rely on domains. It's all domain objects. It's only when we get to the adapter includes the DTOs. And we'll see some code examples of that in a little bit. So again, I have integration tests on the adapters, but I'm only testing what the adapter is responsible for. And so if you look at sort of this sketch, we can see that each box or hexagon has unit tests that are contained within those boundaries. And so what I want to do is make sure that I can test, as much as possible using these unit tests, because they are faster and easier to write. But sometimes I need to test some of the boundary crossing. So for example, the yellow lines coming in from the left and upper left show that I can test the adapter through the core domain, because I might want to do a little bit of checking that I wired things up correctly. But those are going to be the minority of my tests, right? So those are sometimes called focused integration tests. I might have a few then, like the orange line that comes in from the upper left and goes to the lower right, an end-to-end test that uses everything that you'd have in production or as close to production as possible. But again, that's in the minority. All right, so let's look at ports. So we've looked at the adapters to handle incoming things triggered by the outside world. Let's look at the ports. So ports are abstractions and concrete implementations. Whereas adapters, we didn't really have any abstractions other than our service, which was inside of our core domain. The ports are an abstraction that we need in order to define how our core domain is going to initiate communication with the outside world. But again, the ports here are inside of our hexagon. That means they are talking in the language of our core domain. And so for example, if we wanted to send an outgoing message or an outgoing email, we would create a port, and then we'd create an implementation of that would be that would handle communicating with the outside world. So if we look at the steps for defining a port, because they're a little bit more, there's a little bit more to it, as I mentioned, than the adapter. The step one is to basically define the ideal interface that's in the language of the domain. So an example of that, and this is going to be driven by unit tests, is something like this. Let's say we want to send out a notification if the balance changes on an account. So we can see here the package is in the domain package, and we'll look at packaging in more detail towards the end. And here I'm defining an interface. How would I like my core domain to communicate to the outside world that the balance changed? And in this case, I basically want to say this account's balance changed, and it changed by this much. But it's in the language of the domain. Now, because it's in the language of the domain, I can easily write tests for it. I can talk about it in terms of my domain. But if I want to do some tests that involve it, then I use something like a SPI. And so I'm using a very specific term here. As I mentioned, the idea of testables comes from Gerard Mazzaros and some others who've defined things a bit more explicitly than sort of just using the word mocks. So in this case, a SPI is something that can tell me not only did some method get called, but did it get called with the correct parameters. So you can sort of think of a SPI as having a secret recorder recording every interaction with it so that it can report back. So what this looks like in an actual test is something like this. Here I want to make sure that my core domain code, my business logic code, has been wired up to correctly call the balance change notifier when the balance changes. So here I create a mock notifier. Technically it's a SPI, but I'm using Mockito here. And when I create the account, if I do a deposit, then I expect that the balance changed method will have been called with the account and $25. And that's my validation that I have wired up my code correctly. And up to this point, I don't yet have necessarily a concrete implementation of it. And that's really good, because then I can write tests and think about my design, think about how my objects interact with each other before I really sort of settle on, okay, this I think will work well. And once I have that, then I can go on and create a concrete adapter. And so this is the outside world infrastructure-based implementation of that ideal interface. So one might be a text message version. So here I've got an actual implementation. Underneath it uses Twilio, but I've abstracted out Twilio itself into just a generic text message sender. But here we can see at the top that the package it's in is in the SMS adapter, because this is things that deal with SMS. If I don't have SMS in my application anymore, then I would just unplug this and remove the entire package. And so we can see that it implements the balance changed method that takes the domain object, the account, and then queries it to get the balance. And so again, it's the adapter's responsibility to convert from domain to the outside world. Here even, there is no DTO, it's actually just a couple of strings because the text messaging SDK only cares about some strings. So the text message sender says, what phone number you want me to send it to, and what do you want the text to be? So sometimes DTOs aren't even necessary if the outside world you're communicating with just needs text. The nice thing about this is it makes it also very easy to substitute a sort of no-op version of the notifier. And I actually had to do this because when I was testing, I was constantly getting texted every time I was playing around with the deposit. I realized I don't want that always to be the case. So you can use techniques like feature flags so that at startup it can select between a specific implementation. And so this is a nice outcome of having abstracted out communicating with the outside world to a port. Makes it very easy to plug in and swap around these things. And so here I've got, using what's called a null object pattern, basically this is a do nothing. When it gets called, it just ignores it. And so you might also do something similar when you're testing, is have a stub notifier that looks very much like this, or maybe you might even instantiate this directly in your tests, so your tests aren't basically going and talking to real text messaging systems. And you'll notice that the package that this is in the domain because there's nothing about it that deals with the adapter. It's not specific to any one adapter. Now you could argue this might go maybe in just a base adapter package, but that would be a minor nit. So far you can see that there's a lot of things where the domain objects need to stay in the core, and that the adapter is handling the transition from domain to DTO or to strings, and vice versa. And so this leads us to the dependency rule, which is dependencies only point inwards. And so what that means is that you can have adapters depend on your core application. And so from a technical standpoint, they can import things from the domain. So in your adapters, you can have importing objects from your domain package, but the reverse is not true. You do not want your core domain touching or importing or knowing about anything that are in the adapters. And so remember, the adapters are not just the maybe controller classes, but also include the DTOs or other infrastructure or framework specific things. And on the right side, we see the infrastructure adapters which plug into the ports. So again, because we want the component being able to talk to the outside world, then we have to have some abstraction to do that. And this process of our core application talking to a port and then plugging in implementations from the infrastructure is basically dependency inversion. We're inverting the dependency since we don't want the application core talking to specific adapters. We want some interface in between. And so the dependencies from both sides point inward, and this works really well as a rule. And in fact, there are ways to enforce this that I'll talk about later. So the last kind of port I want to talk about, because it's one that is almost always used, is persistence. And so there's this idea of persistence ignorance. So you could sort of think about the example I showed before as sort of infrastructure ignorance, basically not being concerned with, is this balance change notification message being sent by a text message, by an email, carrier pigeon, who knows? And so persistence ignorance is also the case here, which is where we now have repositories for finding and storing our entities and aggregates. And again, those talk in the language of the domain. So here we have a goal repository. So the Kid Money Manager has ways of tracking goals that my son might be saving up for, users, because I have user profiles, things like that. So again, we do not want our domain objects to leave. They need to stay inside the core domain. So we can't directly talk to a database. So instead, what we want to do is, like we did with the balance change notifier, is create a port. Now this port is probably going to be, you're probably going to have this be a little bit less flexible in terms of defining it, usually because they look very similar. Your repositories tend to look very similar, right? You've got save, you've got find, maybe delete, and variations on sort of on that theme. So they tend to look much more alike. But the nice thing is that once you define the port, you can create a fake one. And a fake is basically mimics the real thing, but doesn't have some feature that the real thing might have. So for example, you could create a fake repository adapter that stores all that information in memory. And in fact, when I was developing Kid Money Manager, I did this for quite a long time before I finally implemented the real thing to talk to a database. And that's nice because I didn't have to worry about constantly changing how I'm saving stuff in the database until my core domain settled down and I figured out what I really needed to hold in account and transaction and things like that. So once you've got your fake and you've gotten a certain way, then at some point you're going to create a real version, and this is going to be your repository adapter. So like other adapters, it's going to be responsible for translating your core domain objects and mapping them to tables. And how much of work you do versus your framework does is up to whatever framework you're doing. You might be combining multiple entities into a single entity, or most likely, certainly, collapsing value objects into parts of an entity that gets stored. But if you see here from the diagram, what gets stored are something like DTOs. And so that way, again, you provide this buffer between, well, I need to change the way I'm storing these value objects in the database from my core domain. And in Spring, I do this in the application using the JPA repositories, which are super easy to define. They're basically just interfaces. And so I end up with the interface, so that's being sort of the concrete implementation. And then I have adapters, which for the most part just delegate. And so their responsibility is just transforming the core domain objects to DTOs and then storing those. So now that we have an architecture, we know where things go, that really helps us with our packaging. So this packaging diagram here is from the Kid Money Manager application. So on the left, we can see at the high level that we have an adapter, an app config, and our domain high-level packages. And so you can see in our domain, this is where all our business stuff is, our accounts, our goals, our roles, transactions, things like that, as well as repository interfaces and the balance change notifier interfaces, right? So those are the ports. Some people like to put those things in sub-packages and name them as port. I've tried that. It makes me a little uncomfortable because now I've grouped together things purely for technical reasons. So I haven't found that to be helpful. I will say, though, that the number of domain objects I have is probably getting to the point where I might subdivide them based on features. So I might subdivide them based on, here is user profile related domain objects. Here is sort of the transaction account related things. But the application here is small enough that I didn't feel the need to do that. On the right, we see sort of an explosion zooming in on the adapter package. So we've got 3 packages underneath that. We've got the JPA one, and so as I mentioned, this is the one that's responsible for storing and retrieving information from the database. And so I've got DTOs there for my goal. I got a user profile DTO and the repository interface. So that's the Spring Data class, the interface that I need. And then the adapter that adapts from my ideal port interface to the repository. If you look closely, you might see that there's a missing transaction DTO, and that's because that's one that I actually have not separated between the core domain and the actual database. So there I violated the separation between core domain and outside world, and that has caused some problems. And so that's a refactoring I'm going to do. Under the SMS adapter, we can see all the stuff relating to SMS. So we've got our commands, our parser, our controller, things like that. And then a concrete implementation that I'm currently using Twilio for my text message sending. And then at the bottom, we can see that the web UI is in its own package, and I've somewhat subdivided it according to features. So I've got all the stuff relating to goals in one sub package. And there isn't a lot else there, so that was the only one I had sort of put in its own package. And so with this packaging structure, we can actually enforce it using something called ArchUnit. And these are JUnit-like tests that can basically be a failing test if, for example, an adapter relies on another adapter, or if you accidentally have your core domain relying on something that's in an adapter. And it can basically have a failing test. And so you can really enforce the package structure, and that will help you sort of keep your modularity. And this is where it's like, I think it's fine to have a monolith. And if you have something like this enforcing the separation, then you can get really far with a monolith. And even if you don't like, or maybe you have multiple teams working, you can actually have a separate team working on an adapter, because there is this well-defined interface between the adapter and the core domain, and that's your service. That's probably less likely, but it is likely that you would have possibly separate repositories for your adapter versus your core domain. Now, there are a few places where I would say don't bother using Hexagonal, right? Even though I think it's a great architecture that really scales from small microservices up to larger monoliths. If you've got a basic CRUD app, don't bother. If your domain is pretty tiny, don't bother there either. Or if your app is of a sort of a different type where you're sort of doing transformation, like I was working with one company, and it was pretty much one part of their app was taking messages that came in, transformed them in some way, and then wrote them to a database. Not a lot of logic there. So very much closely tied to if you're using domain-driven design, then you probably want to take a look at this architecture. If you're not using domain-driven design and you're not having any problems and it's really simple, then maybe this architecture is overkill. But I still think that thinking about things as core domain and adapters, even if it's small, even if you just have a few classes, just thinking about it that way can really help make sure you've got your test isolated. So with hexagonal architecture, you want to focus on your core domain. As I mentioned, that's where domain-driven design is a really great thing to use to help you get that core domain correct. Domain objects never leave, and you never accept a domain object from the outside world. You're always using the adapter to do the transformation, either from strings or from DTO objects into domain objects. And again, that helps keep that isolation, that protection layer. Adapters per trigger type, it's not a hard and fast rule, but it's definitely a good guideline. If you have multiple, certainly if you've got web UI versus something like SMS text messaging, they may look similar because maybe they're both accepting HTTP requests, but they really are different. And I'd personally rather have a few more adapters than sort of fat adapters with lots of intermixed stuff. Ports are the ideal interface to the outside world. And so you define them that way, and you can do it TDD. I've developed all my ports TDD, and then plug in concrete implementations later on. And the dependencies point inwards. And as I mentioned, you can use something like ArchUnit to enforce that. And finally, package based on that architecture. It will make things easy to find, and you will know also where to put them, right? If you're creating your command parser for SMS text messaging, you know exactly where that goes or where to look when you have a bug. So that brings us to the end of my slides and presentation. And at this point, I'm happy to take questions. If you need to go, that's totally cool. I hope this was useful. This is my contact information. If you want to learn more, the link to moretestable.com, you can sign up on the mailing list and get information about when I get early access to the course I'm working on that goes much deeper into the code, how to develop it using TDD and other mechanisms. And it's basically a Java Spring-based type of course. So at this point, I'm happy to take any questions. And if you need to drop off, you feel free to do that. But go ahead and type your questions in the chat. And as I mentioned, I'm going to hang around as long as people have questions. So if you either have no questions or you're not interested in or don't have time for hearing other things, then have a great day. And I hope this was useful for you. Is there a .NET version of, I assume you mean ArchUnit. There's something called ndepend, but I'm not sure if it's quite the same thing. I don't know. Yeah, I don't know if there's a .NET version of sort of the ArchUnit thing. It wouldn't be hard to write, and so that's why I'd sort of be surprised if there wasn't a similar one. But I don't know if there is one. Great, Ian. Thanks for coming. Appreciate it. And again, I'm gonna do this webinar again in September, so that way, if you or your colleagues want to catch it again and ask questions, then I'll announce that. And again, if you go to moretestable.com and sign up there, I'll announce the next webinars. Yes, adapters are in the outside world. They are participating in the outside world. They're talking to the outside world. They're sort of the interpreters to translate what the outside world is doing to the safe inside core domain and vice versa. NetArch test. All right, well, there we go. And if there are any other questions, just type a question mark so I know that you're typing a question. But as I said, I'll hang out basically until you all leave or I've answered all your questions. And again, the code for this is up on GitHub. Hit me up on Twitter if you can't find the link. And this presentation, if you want the slides, I will also have them available. If you go, again, if you hit me up on Twitter or if you sign up for the moretestable.com email list, I will email out a link to the slides. They're also up on GitHub. And that's okay. Well, we can disagree. We can agree to disagree, and we can use another venue to talk more about what you see differently about the architecture. Because I'm always willing to learn and adjust. I have been doing so as I've been playing with this. And one thing that's always been sort of key in my mind is how testable is it? How easy is it to write tests for the thing? So. All right, so I think there's no other questions. If you come up with any other questions at any point, as I mentioned, you can email me.